and cooperatives in India, Kenya, Nepal as they continue to rapidly expand. Milk production side IoT intervention includes sensors in the milking system, such as electronic milk meter, sensors to monitor functioning of the milking machinery, animal wearables such as cow pedometers, and RFID ear tags and Android applications to scan and capture data from small farmers who cannot afford automation. The data acquired is used by the cloud-side analytics and machine learning algorithms towards yield improvement, preventative healthcare, accurate oestrus detection to reduce inter-calving periods, nutrition improvement, optimized animal insurance, reduction in cost of operations. The data acquired at the milk production level by smart farms is used in the next hop of the supply chain. Milk procurement side IoT intervention includes sensors for analyzing the milk quality, assessment of adulteration, eliminating antibiotics-laden milk, access farmers' performance, and building traceability back through to the first hop. That is milk production, and provide pertinent farmer advisories. The data acquired is used by the cloud-side applications to determine procurement center ROI improvement, enhanced traceability, regional assessment of milk production pattern, assess routes amenable for premium milk production, automated and real-time farmer payments. The data acquired at the procurement level by Smart AMCU is used in the next hop of the supply chain. That is milk cold chain. Milk cold chain side IoT intervention includes sensors for assessing milk temperature, volume of milk, energy optimization, pilferage control, building traceability back through to the second hop, i.e. milk procurement and logistics optimization. The data acquired is used by the cloud-side applications to ensure adherence to the cold chain protocol adherence, determine quality of milk, preventative maintenance of milk chilling equipment, KPI-based rating of the various nodes along the cold chain. The data acquired at the cold chain level by contract is used to correlate data acquired from previous hop of the supply chain. That is milk procurement. Stellabs, smart systems, stellar applications.
So as you noticed from the video, what we essentially do is we try to collect data from across the dairy supply chain. We don't limit ourselves to one part of it. That is, there are people who sell a lot of hardware into milk production, people who sell a lot of hardware into milk procurement. But what we essentially do is, for us, hardware is the necessary evil. We just need it to acquire the data. We try to commoditize the cost of hardware and focus on shifting the center of gravity to the software. That's our background as a company. So we collect data across production, procurement, cold chain and cold chain logistics, and then try to correlate the data on the cloud side, apply machine learning algorithms to see how to improve productivity, how to do preventive healthcare. I'll give you one or two examples in the interest of time before Viren nudges me. I will try to give you some examples so you get a better appreciation of what we do. We have integrated with multiple sensors, both on the animal side, on the milk procurement side, and the chilling side, and they're all related. And the reason why we take a supply chain view is if you only focus on data, that's only one part of the node or one part of the hop. It cannot be correlated unless you have data from the other hops. So the whole idea is if you collect data across the chain, it makes it much more correlatable. It lends itself more amenable to machine learning and all of that. So we've sort of taken a supply chain view of the entire dairy, and it can be extended to any other segments. For us, milk is just one crop, agri is just one segment. So it can be applied to any supply chain where you can actually insert sensors, collect data, and then try to apply machine learning to optimize and remove inefficiencies. So we've sort of taken a full stack view of the software. So as I said, we are fundamentally a software company. What we have essentially done is we have extended the notion of a service delivery platform to the sensor network side, not just the software side. What this helps us do is it helps us move the physical world of sensors into the application realm. So if you are an application developer and if we want to realize the notion of an app store, an IoT app store, it's pretty important that the physical world of sensors be made, be rendered in the application world via developer-friendly APIs. So I'll not go to the details. Just suffice to say that our stack spans both the sensor network side and the cloud side, and you can use developer-friendly APIs to realize specific applications. We have used this in the dairy space, but as I mentioned, you could use this with minor adaptations in any other segment as well. So this is an example of a deployment example. We don't normally develop our own sensors or sensor modules. We integrate with third-party sensors. Our focus is on the sensor platform, the embedded software into which you can plug and play these sensors. But in some cases where the unit economics does not work, or there are proprietary interfaces, we'll end up developing the sensors ourselves. So this is a sensor that we jointly developed in collaboration with IIT Madras. It's an electronic milk meter. You can actually deploy it in farms as small as 10 to 15 animals. You don't need to have large farms. You could deploy it in very small farms. It's completely cloud-based, not integrated with the local equipment. Unlike many other hardware-centric players out there, which is pretty expensive and cannot be used in emerging market context with 10 to 15 animal type of farms. Those technologies are applicable if you have several hundreds of animals. So if you have a huge Wisconsin-style farm with several hundred animals, then it works. But if you have 10 to 15 animals, then it doesn't work. And two, this is completely software-based, completely cloud-based, so you don't need any computing on-farm. A very minimal computing on-farm, and you push the data over to the cloud, and all your machine learning algorithms runs on the cloud to determine various attributes. This particular sensor, for instance, helps you measure the cow milk conductivity, yield, and temperature. Conductivity is indicative of somatic cell count in the milk, which can be used for preventive mastitis detection at a subclinical level. Similarly, it measures temperature and yield. So combinatorially, when you analyze conductivity, yield, and temperature, it helps you determine many more animal issues and can effectively intervene at a subclinical level. This sort of shows you our platform approach sort of shows you how we use the electronics as a tool set and which can be applied across the various use cases. We have a very modular design, as I showed in the first slide, divided into multiple layers, and each layer, the layer spans both the sensor network and the cloud side. On the sensor network, the various layers runs on different electronic modules. All of them are in-house design. The sensors are typically third-party, off-the-shelf sensors, but the other modules are completely in-house designed. The key message here is that it can be used across use cases. You don't need to develop different electronics or different software for different use cases. You can have sort of a framework-based toolset approach, modify the configuration, and it can be applied to different use cases. This is an example of an animal wearable. Again, unlike an in-premise-based animal wearable, this is completely cloud-based. The cost of the hardware is so commoditized that you could actually go to market with a pure subscription model. We are thinking of launching it in for 2-3 animal farms where you can actually model an entire village as a farm. Typically, you'd see animal wearables in large farms, animals with, farms with 100, 200 animals. But how about 2-3 animal farms, right? So if you model an entire village as a farm, and if it's a zero capex model, it's completely subscription-based, then even a 2-3 animal farmer can afford such technologies, right? So this is made possible, and this again an exception where we went ahead and developed the pedometer ourselves. We normally integrate a third-party sensor, but again, we did this because we wanted close to a zero capex type of an hardware. Because in emerging economies, you can't charge for hardware. You need to go with a subscription-based model. The unit economics wouldn't work if you use a third-party hardware. So again, with the help of IIT Madras, we went ahead and developed our own hardware so that we shift the center of gravity from hardware to software. This is an example of this usage of the same technology on the milk procurement side, because in emerging markets, the supply chain is you start with milk production, farmers pour the milk into a milk procurement center, from there it goes to a chilling center, and from chilling center it goes to a milk processing plant. So this is the next stage in the supply chain. We again use the sensors to collect various data and correlate this with the milk production data. The last hop is the cold chain. Multiple milk procurement centers get the milk into a cold chain center. In the milk cold chain center, we check as to whether if the milk is getting over chilled, is it getting under chilled, how much of diesel is used to chill the milk. Are the cleaning protocols being followed? Are they doing all the appropriate cold chain protocol adherence? Are they being followed too? So we measure about 6 parameters, both equipment-related as well as milk-related parameters. All of these data is rendered to the end user in the form of an actionable analytics, so that the end users are not very tech savvy. So you need to tell them, look, sell this cow tomorrow so that you can save 2,000 rupees. It has to be sort of in your face, actionable analytics. Today, as we speak, we have scaled. We touch about 7 billion liters of milk on our cloud. In terms of number of farmers, number of procurement centers, we have scaled quite a bit. This is a result of what we have done in the last 18 months of taking this technology into the market. That's about it. Thank you.
Thanks a lot. Ranjit, can I now request Siddharth Chaudhary to please. Siddharth, as usual, as you go later in the session, the pressure on time becomes harder.
Right. Well, till we set this up, I'll just briefly introduce me. My name is Siddharth. I am speaking on behalf of Cropin. I work there as the Chief Revenue Officer. I am a marine engineer. I was sailing on board oil tankers for 4 years. I did my MBA from IIM Ahmedabad, and then I decided to work in the agribusiness. And so since then, I have been close to the agribusiness and the rural market. I have briefly worked in a social enterprise where I was setting up drinking water plants for underserved areas in India and Africa. The reason I joined Cropin is because technology is something that has, we've seen the session today, a lot of scope of using technology in agriculture. That is the next big thing, and with the objective of increasing the per acre value for growers. So Cropin has been there for 6 years. If I talk about the two major problems, why Cropin is doing what it is doing, the number one problem is India has the second highest agriculture land in the world. While we all saw today that in terms of the output from those agriculture land, our per acre output is very low. We are the lowest across the world. The second problem again is that a lot of farmers are now moving away from agriculture, and if you see the trend, 10 years back, which was a village, now has turned into a C-class town. So farmers, for them, the incentive to sell the land rather than farming is a big problem at hand. So with the objective of making farming lucrative for the growers is why we do what we do. So there are various possibilities, some of which were discussed today. So I would touch upon some of those that we are working on. So we work on an ICT-based technology. So a farmer uses a mobile phone to capture information at the farm level, and all of that gets integrated onto the web platform in terms of dashboard and reports, which could be used to help him increase productivity. So suppose a farmer on his mobile goes to his farm and does some basic input of his name. He presses a button called geotag, and the geo coordinates of his farm gets captured. And then he does an area audit of his farm. So he touches an area audit button on his mobile, and he walks around his plot, which would capture the area of his plot. So once he does that, so we then would be able to help him plan his farming as a business. Now, how do we do that? So basis the geo coordinates of his plot, we would be able to give him insights about what is the crop that he should be growing this year. So using multiple different platforms, including satellite image, we would be able to tell him what he should be growing. Looking at the timestamp, we should be able to tell him this month, in your region, this is a popular crop, so this is what you should be. So the system would throw up the possible options. So in this case, as an example, tomato has been shown here. So suppose he selects tomato, the system will calculate what is the ROI of sowing tomato in this particular season in that particular region, looking at all the historical information, looking at satellite image. and the disease and pest incidents, and looking at the weather patterns. Now, then we customize his crop plan according to the crop, including something like a value add, which is called plant population kind of analysis. Now, there are researches which a lot of organizations are doing. There are researches which scientists are doing about what is the optimum plant size, plant population. So when you bring down the row to row or the plant to plant to an optimal level, you basically increase your plant population without impacting the yield. So hence you increase the farm revenue from his small farm. So those are the kind of inputs which could also go in, which would again increase his revenue. So the objective is to look at his plot as a business. Now, there are other researches about crop rotation. So the app would suggest which kind of crops he could grow. The app could look at the satellite data and tell him that your land has been barren for 2 months. You should be growing during this season. You should be growing, say a beans or a potato. So then again, looking at whether that second crop would help regenerate the nutrients in the soil. So all of that analysis could possibly happen. Here again, the farm income goes up. And then there are real-time alerts and notifications, looking at all the 4 parameters of disease, nutrient deficiency, looking at pest incidents, or if there is a weed. So as an example, if you look at the screen, looking at his geo-coordinate, the mobile would throw up information saying that one alert, there is a late blight incidence across your village. Now, so the satellite image would help us track what kind of disease incidence is happening in his area, and that kind of information could be sent to the farmer. And then the image of his plot would also be a part of it, where we would point out in the northeast corner of your plot, there is an incidence of late blight. So, and hence, this is the corrective action that you could possibly take. The other thing that could possibly happen, and we are doing, is the benchmarking of his plot. So today we can do it nationally and regionally, but tomorrow, because we are working in 4 other countries and we will be working in 10 more countries in the next 2-3 months, so we would be able to benchmark his plot against international standards also. So today we have 200,000 farmers on the system. We are managing 1 million acres. So some of those interactions are mentioned on the screen. I'll just go ahead. If we look at the kind of, so farming as a business is a billion dollar, billions of dollars are spent by farmers in this industry. So today we are present in the segments. If you see around 70 to 80% of those segments where the farmer needs help. This has been broken down on the basis of farmer interactions. So right from the time he selects a crop to the time he sells his harvest is what we've been. So in those we are present in 70 to 80% today. Apart from the farmer product that I was talking about, this is where we are. Today we work with businesses who work with farmers. We work with the government. We work with the Department of Horticulture. We work with developmental agencies like World Bank and USAID. And then we are doing other projects with organic companies. So we are broadly across segments, working with different companies and different government who works in turn with farmers. We have a smart farm solution, which is a farm management tool. And we have a sales solution for companies who sell something to the farmer. And then we have a packaging solution where we give end-to-end traceability from farm to fork to organic companies or exporters. And this is the last slide. So we are reaching 17 countries now, and we have worked with across 100 crops. So the system is configurable across crops, across regions. So there is a certain component that has been built over a period of time, looking at the experience of other businesses who work with farmers, and we've built the system in such a way that part of the system is fixed. And then there's a second part of the system which is completely configurable according to the business needs. So we won 6 awards, and then there's some write up there about a few countries that we are working in. The major thing is I would end this with a short story. Around 6 years back, I was visiting a mandi in Maharashtra, and that was the harvest season for cotton. So we were meeting our growers who used to buy seed from us, and we were there to ensure that the quality of the produce from our seed is good enough for him to fetch a higher price at the mandi. So we went to the farmer. There was this stock of bale of cotton he was about to sell. On top of the bale sat a young boy who was the son of the farmer, and he was wearing a school uniform. So he caught my imagination, and I went and talked to him, and I asked him where he studies, and he said he studies in a government school. And I asked him the usual question which most of us Indians ask about what do you want to become when you grow up. So he told me that my father is about to send me to a better school in a city because I want to study plant genomics, because I want to be a scientist and I want to help the farmers of this country. So that kind of helped me understand that the things are changing. A son of a farmer does not necessarily want to become a farmer. He wants to maybe become a scientist, or he wants to run a business. So for all the minds that are sitting here and people like us, we need to work towards making farming a lucrative business, so that while the son of the farmer may become a farmer, the existing farmers continue to farm. Thank you.
Thank you, Siddharth. I now request Mr. Suraj Dixit, Founder Managing Director at Nubis All India. Suraj,
Sure.
clock's ticking.
Good evening, guys. We are at the last leg of the session. So I'm sure, I'll assure you that it's going to be a better one, and hope I'll not bore you guys. So I'll make it a quick one. So digital connect to scale farm extension is the topic. So basically, since we are talking about digitization in agriculture, data-driven innovation in agriculture, and the session topic is all about the innovation and the entrepreneurship. So I would like to go with the innovation that we are doing at the farm extension level. Okay, as a NUPSOL, the product suite, we have a crop information management system, which is a real-time crop platform which gathers lots of data with regards to weather, with regards to crop. Every activity of the farm is being captured, which is used for the analytical purpose. So remote sensing reports, so we, in the last 3 years, we have been working mainly on the remote sensing in terms of understanding the crop health, yield estimates, yield threats, and then how we can convey to the farmer. And recently we have added the soil card, which is a digital soil card program that we call, in which we are enabling the agri-businesses, like for example, sugar industries, to enable their farmers to know more about their lands. And what we do is we use a scientific way of reaching out to the soil health, and then that we use it as a background information to give more accurate recommendations. So Krishi Suchak is the last product in our suite, which I am going to deal with now, which is the latest innovation that we have done for the farm extension services. Okay, so what are the farmer problems? So farmer problems are varied, which crop, market rate, I have this pest, whether it is a pest or a predator, which fertilizer to use, how much to use, soil testing, which place, plenty of them, right? So if I have to assimilate entire problems, so I can come up with poor farm extension services that is currently there. That is, farmers' inability to assess the crop health, identify the yield threats that are going to be commercially, important to him, identify the risk factors like climate, weather, for example, as part of the crop planning. So whether it's going to be a good season of the rain or not, which crop to be used, prevent spread and outbreak of damage. How can we stop the damage being geographically propagating? So all the problem on the spot. So this is one of the major requirement of the people. And so this is currently being assimilated as around 45,000 crore loss to the nation in terms of the crop health. So that's where we are trying to concentrate upon. So the traditional approach has been to go to the farm levels, interact with the farmers, and then help him out with the issues. Okay, and when which the traditional farm extension activity is very low in India, and could serve only limited number of farmers. I had only 5% of the farm extension outreach is there currently. So there has been some innovations in the past that has been done to grow the reach in terms of like extending it through the call centers, wherein the farmers would be able to call in, and then there is going to be service that is going to be given. All said and done, this is a capacity intensive program in which one-on-one engagement is always there. So what we are trying to do is digitally how we can scale this particular platform so that more people can be benefited with less number of resources. Okay, and one more thing that is happening now recently is in the age of social media, bombardment of information is happening for the people who are going into social media to ask for the issues. Like for example, I recently encountered an Arcanet grower issue. Like he asked, like, what is this particular problem? And there was 27 replies to that. And ultimately, at the end of it, he was not sure what is going to be his actionable input. Right? So on one side, there is an information gap, and the other side, there is a huge information that is on the social media. So we have brought up a Krishi Suchak Android digital platform. It's just like an WhatsApp interface in which farmer would be able to engage with us, transmit pictures, videos, audio, and then text message, clearly explaining about his particular problem. And what all we address as part of Krishi Suchak is pest and disease management, nutrition management, and the crop care alerts, market services, expert advice, e-commerce, and then the complaints and redressal. So, for example, like, it's about what we call it is each interaction is an opportunity, and then the methodology or the algorithms behind it ask more intelligent questions so that the answers can be taken further for the algorithms to work upon. These are the few examples of interactions that happen. So the model that we work upon is intelligent routing with respect to the queues. So we have intelligent algorithms that has been put across in terms of understanding the text messages, replying it more intelligently without any intervention, as well as a speech recognition that we are introducing in, where we can understand the keywords and then probably would be able to answer him much. So we are connecting an ecosystem here. So the consultants at the ground level, the Agri University our extension program workers, we are connecting, and then we are also serving through the automated process. So this particular platform, so we are integrating some of the advanced technologies that we have been working for around 3 years. That is in terms of precise recommendations through the soil nutrient analysis that we are doing, along with it precision application information, which is going to be yielding to the high productivity at lower costs through this particular application. So farmer would be able to see his own land and how the yield map is doing over a period of time, so that there is enough intervention opportunity for the farmer to intervene in between and then arrest the crop loss. This is more of an command area view that is from the web perspective. So what is the innovation that we are doing from NUPSOL? Industry specific solutions, maximizing the adoption and the impact. It's more of product. It's more of taking an impact onto the ground rather than more of product development. So industry specific solutions, I mean by sugar industry solutions, like how can we help the sugarcane farmers improve their yield while minimizing the risks. Weather agnostic remote sensing, that's been a very challenging area, and that we are mastering that. Crop specific decision support model leading to accurate yield predictions. So we are specializing algorithms specific to the crops in which the decision about the yield threats, yield predictions are much more accurate. We are integrating artificial intelligence at every possible step so that the predictions are much better. This new innovation that is technology-driven, one-on-one contextualized individual advisory services that we have just recently launched. Advanced image processing that is in progress, where we are trying to understand how we will be able to derive what is a nutrition deficiency or the pest issues are straight out of the images. We undertake, so we implement everything in